Assalamualaikum warahmatullahi wabarakatuh and good evening. My name is Muhammad Syafiq Zadi bin Jumat. My matric number is CD210311 and I'm gonna to present about my PSM2 project. The title is to design an automated nut silo system with integrated temperature and moisture sensing to optimize kernel release. And for my supervisor for this project is Haji Abdul Khalil bin Abdul Rahim. And I'm gonna start with chapter 1 for the introduction. And for the problem statement for my project is for today the manual monitoring with temperature gauge and moisture check. And because of that, it may cause the time consuming, labor intensive and prone to human mistake. And so for the problem statement is and for the objective for my project is to design an automated system that integrates temperature and moisture sensor to continuously monitor the drying condition within the nut silo using SolidWorks. And for the second objective is to design a pneumatic actuation mechanism that automatically opens the discharge door when the optimal temperature and moisture level are reached, reducing manual intervention and ensuring consistent quality of the relay kernel using SolidWorks. And for the scope of study is this project only can be used by genting air hitam oil mill and include a discharge door that is made to work seamlessly with the pneumatic actuation system. And for the synopsis for this project is improve manual kerning drying and release system in silos. And for the currently the process relies on manual checks which can lead to errors. And of course, this setup will reduce the need for manual checks and ensure the kernel are only released when properly dry. And this project aims to enhance efficiency and improve the quality of kernel processing. For expectation for this project is improve kernel quality with less spoilage, and secondly is significant cost saving from reduced labor needs. And for the chapter 3 methodology, I'm gonna present here about the flowchart for my project. So as you can see, for the first we go to the project setup, and then for the next step we to gather information. So after we gather the information, we divide in the two parts, which means we have a design discharge door and using SolidWorks, and design control system for the temperature and moisture sensor. So for the design discharge door here, we have the pneumatic system actuator, and of course the flat door for a kernel release. And for this part, we design using SolidWorks, and after we design, we make the calculation for the flap door. And after that, for design control system, there's a few components that we use for it, like a moisture sensor, Arduino IDE and temperature sensor. So with this component we can design the control system using Arduino IDE software. And after all of this, we gonna calculate the cost evaluation and getting the project done. So for the concept selection for my project, as you can see here, we use the temperature sensor, that is thermocouple sensor. For the moisture sensor is capacity moisture sensor, and the control system we use the microcontroller. And our actuation mechanism, we use the pneumatic, and discharge door we use the flap door concept. Yes. And for the chapter 4 result is I'm gonna present about the overall design. So this is the nut silo that used in industry now. And as you can see at the bottom here is the discharge door. So our discharge door has the two pneumatic cylinders that acting. This pneumatic cylinder is the actuator for the discharge door. So as you can see, there's a double acting and two cylinder or pneumatics. The system here, discharge door mechanism, as you can see here, there's a pneumatic cylinder. Is when the door is locked, the it will release the rod inside the pneumatic cylinder to keep the doors locked. And then after the automation control detect that the temperature and moisture sensor in the silo is fill the inquiries to discharge the kernel, and the pneumatic cylinder will pull the rod inside it, and then the door will flap into the bottom using gravitational force. And for the automation control design, that I used to build the automation control system, I use the Arduino IDE software. So for the automatic control design, I use the Arduino IDE software because it is an essential tool for programming and managing the automation logic of the nut silo system in this project. Is the Arduino Integrated Development Environment. For the automation control design, I use the Arduino IDE software because it's an essential tool for programming and managing the automation logic of the nut silo system in this project. Is the Arduino Integrated Development Environment. The short form is IDE, for authoring, building, and uploading code to the Arduino microcontroller. The software logic that controls the intersection between the project essential parts, more especially the temperature sensor, moisture sensor, and pneumatic actuator system, is developed using the Arduino IDE. The Arduino can catalyst monitor sensor input thanks to the control logic that is built within the IDE. Once the kernel have achieved the required environmental condition, the Arduino will immediately engage the discharge mechanism. So this is the code that I have designed using Arduino IDE. As you can see here, there's a verifiable code for the function, like a constant flow temperature, like this is to set your temperature threshold. It means when the temperature is not reached at 60 Celsius or above, the discharge door will not open. And of course, there is a the few line of the programming design that I create here. And then for this, as you can see here, is a wall boot circuit for the automation system. There's a few additional components that I use, like breadboard, male-female wire, and a 1-2 resistor. As you can see here is the moisture sensor. Connect with this, and then as you can see here is the temperature sensor that we connect directly to the breadboard. And this is that we call is Arduino Uno. It's acting as a microcontroller. And as you can see here, this is an example of result from the control discharge system. When the temperature is 72.19 Celsius and the moisture is 74%, and it meets the condition to discharge the release the kernel. So as we can see, optimal drain condition met, discharging. And then after the discharge complete, the system monitoring the temperature and moisture is continuous. And then for the cost evaluation, as you can see here, there is some cost evaluation for the based on my project, but we don't have the prototype yet. But just the prototype is basically just cover the automation control system that we use Arduino, temperature sensor and moisture sensor, and then we have a relay module and pneumatic cylinder. And then for the cost evaluation, after all of this, we complete the solenoid valve, power supply unit, and the total is 305 ringgit. I'm expected is 305 ringgit, less or more. And then for the conclusion and recommendation. Conclusion of my project is, An automated system was designed and implemented to continuously monitor the drying condition inside the night silo using integrated temperature and moisture sensor. This sensor provide real-time feedback, allowing the system to accurately determine when the kernel reach optimal drying level, thus eliminating the need for manual check and improving the overall consistency of the drying process. And then pneumatic actuation mechanism was developed and integrated with the system to control the discharge door. This actuator was appropriately sized based on force calculation and was effectively controlled by an Arduino microcontroller. The system was programmed to automatically activate the discharge mechanism once the sensor detects that both temperature and moisture met the required threshold. For the recommendation for my project is to increase the sensor accuracy by utilizing digital sensor like DS18B20 for temperature and a capacitive grain moisture sensor. For now, my sensor is using analog sensor, the very old school sensor. And to find the accurate reading, we can use the digital sensor. And of course, the secondly is future iteration could incorporate non-blocking timing using a real-time clock RTC module to enable continuous monitoring even during discharge, even if the current system use a delay-based control to time the discharge. And then I would like to a user interface like an LCD screen or Bluetooth Wi-Fi mobile app can be added to the control system to show real-time readings and enable manual override or dynamically modified threshold settings. That like an LCD screen or Bluetooth and Wi-Fi mobile app. LCD screen and or a Bluetooth Wi-Fi mobile app is we can check the temperature and moisture reading everywhere and anytime we want, especially for Bluetooth and Wi-Fi mobile app. That is very helpful for the operator, and it will make the operator more alert about the condition kernel in the silo. And then for the recommendation is to assess the system under various weather and storage circumstances. Field testing in actual agriculture setting is advised. This will enable more substantial design investment by assisting in the identification of real-world issues including dust, humidity, and wear on mechanical components. So because I'm just design this project. For me, the recommendation is to apply this project into the real world. Maybe build some prototype or try this project to the real manufacturing. Yes, for my project is for now there is no field testing in actual agriculture setting, but I hope in the future these projects can be testing, especially in our palm oil industry and for any agricultural sector. And thank you very much. That's all from me.